Imagine teaching a brain without a body how to play video games. No screen, no eyes, no consciousness, just raw neurons in a dish, learning. In 2022, scientists did exactly that. They taught 800,000 living brain cells to play the classic game Pong, and they got good at it. This isn't a Black Mirror episode, it's a real experiment, and it might just change everything that we think we know about intelligence. The experiment took place at a company called Cortical Labs with a system they call dish brain. They took mouse and human neurons, brain cells, and they grew them on top of something called a multi-electrode array. Think of it like a petri dish, but underneath there are 26,000 tiny electrodes that can both stimulate and read signals from the neurons. Now here is where it gets wild. They connected these neurons to a simplified version of the game Pong. The neurons didn't see the game. Instead, they received electrical signals that represented the position of the ball. The neurons, in turn, could send signals back to control a virtual paddle, moving it left or right. And over time, they learned to play. In less than 5 minutes of training, the neurons began improving their performance and returning the ball more readily. So, how do disembodied brain cells learn anything? The key is a concept called predictive coding, the idea that the brain learns by minimizing surprise or error. The researchers rewarded the neurons when they successfully hit the ball by giving them consistent patterned feedback. But when the paddle missed, they received noisy, random input. The neurons learned to associate certain patterns with success and others with failure. They begin to fire in ways that improved performance, not because someone coded it, but because the neurons naturally adapt. Just like in your brain, when you're learning to ride a bike or type faster, these neurons were literally rewiring themselves to improve. The researchers describe this as a primitive form of intelligence. They call it synthetic biological intelligence, or SBI, and it's not artificial intelligence like ChatGPT or AlphaGo. It's a real, living intelligence, doing something useful in a closed-loop system. Why does this matter? Because it's the first time we've shown that living brain cells can be taught to perform goal-directed behavior, and this opens up enormous possibilities. Imagine testing drugs or treatment directly on active neural nets, or using neuron-based systems to study diseases like Alzheimer's in real time. Some even speculate about combining biological and digital intelligence, brain-machine hybrids. In a way, we're building the earliest foundations of biological computing. Machines that don't just process data, but literally think. Not with silicon, with the living cells. Now let's pump the brakes. These neurons aren't actually conscious. They don't know they're playing Pong, but they respond to feedback, adapting and demonstrating a kind of agency. And this raises some big questions. Could more advanced cultures of neurons actually develop memory? If we train them long enough, could they become sentient? And if we merge these biological neurons with digital systems, what is intelligence really? We're not building brains in a lab yet, but we're getting closer to understanding how we might do that. We taught neurons in a dish to play Pong, not by programming them, but by just letting them learn. The line between machine and biology just got blurrier, and in the future, it could be weird and fascinating. So hit like and subscribe if you want to keep exploring the strange and incredible world of computer engineering and synthetic intelligence.